Yeah, I think now voice is audible, right now. Yeah, look at this. The question says pH we need to find for the given salt solutions. Look at here, we have NaCl, the salt formed from strong acid as well as strong base now. Therefore, the resultant solution which comes after the hydrolysis also neutral only, okay, because it won't undergo hydrolysis first. I think now voice is audible. Yeah. So now look at this, NH4Cl is there now. So take that NH4Cl. So if you hydrolyze this, we will be getting NH4OH plus HCl. Okay, so this is a salt formed from a strong acid and a weak base right now. So it is a strong electrolyte. So I can remove this. Yeah, I can remove this chloride ion here and here because HCl is a strong electrolyte. Therefore, resultant solution is having H plus ions now. So it makes the solution to be acidic. Okay, because HCl is forming. So resultant solution is having strong acid. The resultant solution will be acidic in nature. Okay, so it is acidic. So pH definitely less than 7. Okay, and here NaCN, if you take, NaCN is a salt formed from what? It is formed from a weak acid and a strong base right now, like NaOH will get and HCN will get right now. So NaOH is a strong base. Okay, since it is a strong base, it makes the resultant solution to be basic. Okay, therefore pH for basic solutions will be high, we know that right now. And HCl, we know strong acid, the lowest pH is for this strong acid. So lowest is for HCl, so I can say lowest is for HCl. Okay, and after that highest is for this NaCN. Why? Because NaOH is formed, so resultant solution will be basic. So highest is for NaCN I am writing. Okay, after this, in between this we have two more things here, NH4Cl and NaCl. See, I am saying NaCl is neutral, so pH is 7. Definitely NH4Cl is a strong acid is formed, so it is lesser than 7. So here I can write NH4Cl and in between NaCl, that's it. This will be the order. So look at the options, where do we have this kind of option? See, option 2 here, see option 2, see NaCN is high, after that NaCl, next NH4Cl and HCl. So option B will be a perfect answer. Hope this is clear. Now I will be giving you one very basic and very important question here. See, just take this question. So pH of solution formed after hydrolysis of this sodium acetate. Tell me, so sodium acetate upon hydrolysis, what it will give? Sodium acetate solution, okay, is greater than 7, pH will be greater than 7, or pH equals to 7 or less than 7. Tell me, what is your basic understanding from this? See, whenever they give this kind of salt hydrolysis questions, just add the water to this. So if you add water, what happens? The cationic part of water is H plus right now, so that will be paired up with the anionic part of this salt. See, anionic part of the salt is acetate ion now, so CH3COOH will get. This H is from water and this anion, acetate ion from this salt. And what is the cationic part of salt? Na plus now, so Na plus cationic part of salt and anionic part of water, that is OH minus, will pair up to form another compound. See, NaOH is a strong base, therefore resultant solution will be basic right now, therefore resultant solution will be basic, pH definitely greater than 7 right now. And if you want to find exact value of pH, so they will be giving you something like 1 molar sodium acetate solution having pKa equals to 4.74, find its pH, like this they will ask. Okay, just look at here, what you need to take is pH equals to, what we know, pH definitely greater than 7 now. So for this particular solution, pH 7 plus half into pKa, that is for weak acid, pKa plus log C you put. So therefore you will get the final answer for this particular type of questions. Right now, is this clear or not? Yes, if it is clear, just tell me the final answer you can get for this particular question that I am mentioning it as 1 molar solution. It means concentration C is how much? 1 molar. So log 1 is 0 and pKa value mentioned as 4.74. So just substitute here and you can get 7 plus half into pKa 4.74 plus log C. Log 1 is how much? It is 1. Log 1 is how much? 0, right now. So it means 7 plus, so here you will get 2.37 plus 0. Okay, so by cancelling out this, so 9.37 will be the pH of this particular solution. Hope this is clear. Okay, so if it is clear, just click on the like button and I will be giving you similar kind of question for basic solution. Now look at here, I am giving you one more question here. See, because here the previous question which I have shown, this is IIT JEE 1999. Now the questions, the approaching way of questions is little more different. Now they are asking exact value of pH by using this formula. For example, I am giving you NH4Cl solution having concentration something like 2 into 10 power minus 2 molar NH4 solution having Ka equals to 10 power minus 5, then its pH is, its pH equals to how much? Very simple. Now look at here, NH4Cl. What is the solution? What is the product formed here? Upon hydrolysis, we'll get NH4OH plus HCl. Right now, this is a JEE Main 2022 question. Okay, so previous year question it is, I am giving you here. Okay, so the resultant solution is having strong acid right now, therefore solution will be acidic in nature. Therefore we know pH definitely less than 7, so pH equals to 7 minus half into pKa. See what you need to take, see here they will mention this is pKb, okay, because NH4OH is a weak base, so pKb plus log C you take and substitute the values over here and you will get the final answer. I just want your answer for this particular question. Use the data mentioned here and tell me your answer in the comment box. I will be looking into it. Even if it is wrong, no issues, I will help you in the answer in the comment box if you answer it properly. Okay, whether it is right or not, just give your answer in the comment box. I will be looking into it. Okay, fine. Let us move forward with few more questions. Yeah, look at here. I have one more question from this one, chemical bonding. So just tell me what's your answer for this. Yeah, so look at this. Among the following compounds, the number of species with 2 lone pair of electrons. Just find its hybridization and you will get the answer. SF4 means group number of sulfur is 16 now. So take that valence electron. 16 means 10 plus 6 now. So 6 will be the valence electrons present in the oxygen family like sulfur, selenium, oxygen, sulfur, selenium, all those things. Okay, so put 6 dots like this, just simple. Okay, 3 plus 3, 6 dots over, and fluorine atoms are monovalent now. So just take, if one monovalent atom, one bond, like that 4 atoms are there, 4 bonds, and remaining pair of electron that will be stays as a lone pair electrons on the central sulfur atom here. Okay, it has one lone pair. First option has one lone pair. Next, XeF4, similarly you take 8 electrons for xenon because it is 18th group. So 8 electrons if you take, out of that 8, 4 bonds are formed. It means 4 more electrons are there now. So that will remains as a lone pair electrons here. So it will be getting sp3d2 hybridization having octahedral sp3d2 means, but you know having lone pair electrons, 2 lone pair electrons now, therefore it makes it as square planar. Okay, yeah, so this will be square planar having 2 lone pair electrons. Similarly, if I say CF4 is having just carbon having 4 valence electrons. Each valence electron will pair up with the fluorine atom like this. There is 0 valence electron, 0 non-bonding or lone pair electrons in this particular compound. Next, go for the next one. Water molecule is having again oxygen is central atom here in this compound, right? So it means 16th group element oxygen is, so 6 valence electrons. Okay, it means you put 6 dots like this. Okay, same whatever the story I have given here in the first case for sulfur. Okay, same applies here. Okay, 6 out of this 2 hydrogen atoms which are monovalent right now. So 2 bonds are formed and the remaining 4 electrons will be having set of 2 pairs right now. So 2 lone pairs and 2 bond pair electrons in the like H2 right now. Therefore the lone pair electron species having 2 are how many? This xenon, compound, this xenon compound and this water molecule, right now. So our answer should be 2 for this particular question. Very easy, right? Yeah, hope this is also clear, right? Let us move forward with few more questions here. Yeah, look at this, total number of species from the following which can undergo disproportionation reaction. Very easy, again this question also, see 2024th question, JEE 2024 Jan 30 shift question. Yeah, so look at this, the given molecules, in order to show a disproportionation reaction, the central atom should have intermediate oxidation state. Intermediate oxidation state means, for example, I have an element A, so element A can have possible oxidation states something like from -2 to something like +4, if it is having this many number of possible oxidation state. Now the A should either contain between these two numbers. Okay, if it is having either maximum or minimum, then it will not undergo disproportionation reaction. This is the primary criteria you need to know in order to identify a disproportionation reaction. For example, if I have A -2 or A +4, these two species won't show disproportionation reaction. Okay, this is what you need to understand first. For example, this atom A having oxidation state +1, so now it can undergo oxidation further by losing 1 or 2 or 3 electron, and it can show either +2 or +3 or +4. This is what oxidation is taking place. And now same element by gaining 1 electron or 2 electron or 3 electron, it can either have neutral oxidation state, it becomes A0 or A -1 or A -2. So these are the different possible charges by reduction and by oxidation. Now what do we mean by disproportionation reaction? Means a species simultaneously should undergo oxidation as well as reduction, okay, from same oxidation state. See, the same element undergoing oxidation as well as reduction, those can be considered as disproportionation reactions. Now here H2O2, in this H2O2 oxygen is in -1 oxidation state. Okay, now by losing 1 electron, oxygen can become like oxygen atom, here it is minus like here one oxygen atom is in -1 oxidation state in hydrogen peroxide. Now by losing 1 electron, it can become oxygen atom, or it can lose 2 electrons and become oxygen cation, like that. Okay, so it means oxygen can undergo oxidation, or by gaining 1 electron it can become O -2, which is oxide, this is peroxide, okay, like that. So both possibilities are there now for this H2O2. Yes, it can show disproportionation reaction. And here chlorine is there now, chlorine having +5 oxidation state in this chlorate ion, like ClO3- is given now, in that it is having +5 oxidation state. By losing 2 more electrons or 1 electron, it can show up to +7 oxidation states. Okay, so it can have possibility to undergo oxidation. Now by gaining electron, it can become +1, +2 or 0, like that, right now, or -1 also, like this. So it can also undergo disproportionation reaction. Even phosphorus P4 is there now, so P4 can convert into either negative forms or positive forms. Here oxidation state is 0. Now it can be converts into +3 compound or +1 compound, like that, depending upon the situation. Like it can form oxo acids like H3PO2, and in this case it is having +1 oxidation state. Or it can go reduction by forming like phosphine kind of compounds, where it is having -3 oxidation state. Okay, so I hope this is clear. Now P4 can also undergo disproportionation reaction. Okay, and next look at this, chlorine is there, Cl2 gas is there. Yes, Cl2 also can undergo oxidation as well as reduction, both are possible for Cl2. Okay, so Cl2 can form Cl plus or +1 or +3 or +5 combinations, and it can also form chloride ions. Yes, chlorine can also undergo disproportionation reaction. Okay, and here silver, here already it is in elemental form. Metals do not show negative oxidation states. Okay, so the minimum oxidation state is already 0 here, so it cannot undergo reduction. Therefore I cannot say that silver is undergoing disproportionation, so it won't undergo disproportionation, Ag won't show. And here copper is in +1 oxidation state, Cu +1. Okay, so Cu have maximum, copper has maximum oxidation state of +2. So by losing 1 electron it becomes Cu +2, and by gaining 1 electron it becomes Cu atom. Okay, so Cu +1 can show disproportionation reaction. Okay, and here we have fluorine F2. So fluorine is the most electronegative element in the periodic table. So the minimum oxidation state possible for this fluorine is 0, and it can only show negative oxidation state like fluoride ion like -1 charge, but it won't show positive oxidation states like +1 or any other plus charges. Therefore it cannot undergo further oxidation, but it can only undergo reduction. So it means fluorine also does not undergo disproportionation in this particular example. Okay, next NO2 is given. NO2 here +4 oxidation state. Now it can convert into either +3, +2 or +1, 0, minus oxidation state. It means it can undergo reduction, and it can also have maximum oxidation state of +5. So both oxidation reactions are possible now. So this can show disproportionation reaction. And for potassium, the alkali metals, always remember alkali metals always show maximum of +1 oxidation state in the unipositive nature. Okay, so it can only be in +1 oxidation state, further oxidation is not possible. So this one also don't show any disproportionation reaction. Now count the number of species showing the disproportionation reaction: 1, 2, 3, 4, 5, 6. So your answer should be for this particular question should be 6. This is how you need to answer the questions. Very easy, and basic concept is involved here, right now, right? If this is clear, just click on the like button. Yeah, next I will be giving you few things here. I have manganese. Okay, so manganese can be having +6 oxidation state. So manganese valency electrons are D5S2. This is having atomic number 25. So 3D5 4S2. So 3D5 4S2. So it means only valency electrons will be involving in the reactions. It means only by losing the valency electrons, elements will show their oxidation state, different oxidation states. Now in the elemental form, it is 0 oxidation state having this many electrons. Now what is the maximum oxidation state possible for manganese? By losing all 7 electrons, manganese can show +7 oxidation state. Okay, and other minimum oxidation state something like this, and in the elemental state it will be in the 0 oxidation state. Now tell me, if I give something like KMnO4 and I am asking you whether this KMnO4 undergo disproportionation reaction or not. So what is your answer? Definitely not. Why not? Because already here Mn is in +7 maximum oxidation state, therefore it will not undergo further oxidation. It is only possible for undergoing reduction, therefore it won't show disproportionation reaction. That's how you need to answer the questions. Hope the concept is clear, right? Let us move forward with few more questions. Yeah, look at this. Arrange the following compounds. The one which is having a highest dipole moment is, or among the following compounds, the one which is showing highest dipole moment is. So from the 4 options, we need to identify the one which is showing maximum dipole moment. See, maximum dipole moment means there should be maximum charge separation, because mu is equals to charge into distance. There should be maximum charge separation, then we can say that is having maximum dipole moment. Look at in the first question and the second question. So for example, the looking molecules or the structure is looking neutral, but you know we have a concept called aromaticity right now. So based on that, if you look at the structure and if you understand it properly, you will get aromatic compounds. We know aromatic compounds are highly stable right now. Therefore the double bond here which is present between the 2 rings will become single bond and makes negative charge on the 5-membered ring and positive charge on the 3-membered ring. So by this single bond formation and charge formation, what happened, you just check here, this ring becoming aromatic as well as aromatic, this ring also becoming aromatic with 6 ring pi electrons. Okay, both rings are becoming aromatic, therefore system is stable in this case. Okay, so that's why if the stability is there, more stability is there in this format, then the system will convert, or the compound will convert into this in this manner only. Therefore, two charges are separated. I can say charge separation is maximum in this case. Now look at this case, there is only a 3-membered ring without any pi electrons like in this case, and only a outside external pi bond oxygen is there, carbonyl group is there. Now it can also become O minus and plus here, but we know there is no complete conjugation in the ring, there is no pi electrons for conjugation. Therefore this is a simple non-aromatic compound, right? Now non-aromatic compound. So we know aromatic compounds are more stable, therefore this is making it to be having maximum dipole moment than the B, and even when I compare with the C and D. So why not in C and D? See, if I want to write in that manner, in this manner for this particular C compound, what it will become, just look at here. See, I have one pi bond and pi bond here and here. So if I want to separate this pi bond, keeping negative charge one side and positive charge the other side, see this ring is aromatic, that is fine, but you know what about this ring? See, having cation, carbocation here, positive charge, this makes the compound to be, this ring to be anti-aromatic, which is highly unstable. Therefore the system is becoming highly unstable, one side of the system is becoming highly unstable. So it means bond separation won't take place here because resultant compound is highly unstable. So it will stays in this manner only and shows its non-aromatic nature. Therefore it's a neutral compound, it won't get ionized. And same story here also, it won't become an aromatic ring, it just become like conjugation is possible. That's it now. So it means which is having more stability, only compound A having more stability after forming respective ions, like charge separation in this manner. Therefore first option will be having maximum dipole moment. So your answer should be A. Okay, so again see JEE Mains 2023 question. Okay, and if you are clear with this, I just wanted to give you one more question here and tell me whether it becomes polar or like it becomes ionized or not, whether it should be exist in neutral form or ionic state, you just tell me here. So I am writing two compounds based on the understanding of previous explanation. Just tell me compound A let me change the compound B. Compound B. So tell me, out of these two compounds, which will be exist in ionic form? So how to check? In order to check whether they are in existing ionic form or not, just separate these bonds, like one side, any of the side, putting negative charge one side and positive charge another side, and just look at the structure. The system is becoming more stable by gaining its aromatic nature or not. Okay, if it is becoming or if it is gaining aromatic nature, then we can say the system can exist in ionic forms. Okay, yeah, look at in that manner and tell me which of these two can exist in ionic form, or I can say maximum dipole moment is possible, in which case, or the same question can be asked in other manner. Which are the following compound has rotational barrier, maximum rotational barrier? Maximum rotational barrier means if there is a double bond like this, so that will stop or that will restrict the rotation of the compounds around the double bond. If it is having double bond character, the bond rotation is not possible. So it will be having maximum restricted rotation. And if there is no, if this double bond becoming single bond by formation of ions by resulting aromatic nature, what happens? Only single bond will be there, rotation is easy and flexible. So bond barrier, rotational barrier will be minimum or zero, I can say, like that. Okay, yeah, this is a very important concept when it comes to for JEE Advanced also. There are few questions asked on this rotational barrier dipole moment concept for of this aromatic compound applications. Okay, next here we have one more question. Yeah, look at this, very important. The total number of chiral compounds from the following compounds is So look at this, first option is having this kind of structure. Now just tell me based on your understanding whether it is optically active or inactive or chiral compound or not. How can you answer? See, when you have this kind of compounds, just consider them as allenes. What do you mean by allenes? See, how many carbons are there? Here one carbon and here one carbon, here one carbon, right now. So between the two carbons you have a double bond. I am writing it like this, okay, and between these two carbons, here one more carbon is there, between them you have one ring right now. So you have one ring something like this, 6-membered ring, okay. So this is something like carbon, double bond, carbon, double bond, carbon, like this you just imagine. Now you know these two pi bonds, these two carbons are perpendicular to each other, pi bonds are perpendicular to each other, and if you know if you have the groups here whichever the present on the terminal carbons, like here I have something like one H and one pH phenyl group, and here I have carboxylic acid and one hydrogen, like this. If four different like terminal carbon, if two different groups are there, this side and this side, like AB type, then we can say that compound definitely like optically active, it is chiral, okay. So see here we have two different groups that will present in different planes, okay. So something like you can imagine this as a center point having one carboxylic acid group here and one hydrogen here and another hydrogen here and pH, but you know these two groups are different here, okay, something like that you can just imagine, okay, and compound become aromatic compound become chiral and optically active, okay. So first compound is optically active, it does not contain any plane of symmetry or center of symmetry. So for the other compound, if you see here you have a carbon having four different groups right now, therefore I can say that compound, this particular carbon as a chiral carbon, so optically active this is. And you know this compound C, here we have third compound here, if you observe, okay, if you observe this third compound having plane of symmetry. So if you send a plane between the two molecules of this Fischer projection, what happens? It is dividing into two equal halves, two pieces, equal pieces are coming now. So I can say that as a optically inactive due to plane of symmetry, okay. This compound is called as mesotartaric acid, okay, which is optically inactive due to plane of symmetry. Remember this point, okay. Yeah, next one, you can also pass a plane here. See, if I pass a plane like this in this particular compound, see, OH group below the plane, OH group below the plane, that is making to superimpose on each other, and OH group above, here also above, here above, here above. So after dividing the molecule into two equal halves, we are getting the pieces which is having same superimposability right now. So it means this is also having plane of symmetry, this is also optically inactive, OP inactive, I am writing optically inactive, okay. What about this? And you can also pass a plane like this, yeah. So if you pass the plane like this, see, it is dividing into two equal halves, and this is above the plane, this is also above the plane, both are carboxylic acid groups only. So this is also optically inactive, okay. So therefore the bottom three are optically inactive and top two are optically active. So how many of them are chiral compounds or optically active compounds? 2. So this should be your answer here, option number, like answer should be 2 for this particular question. Hope this is also clear. Yes, if this is clear, just click on the like button, and if you are new to our channel, just click on the subscribe button, and also you can share with your friends and you can write your feedback in the comment box, okay. Yeah, so few more questions here. So try to solve this question, anyone? So try to solve this question. For the first order reaction A to B, the temperature dependent on rate constant in second inverse was found to be follow the equation given like this. Okay, the activation energy EA for E and pre-exponential factor A for this particular thing is they are asking. So just take your Arrhenius equation and compare with this, therefore you will get the answer. Very simple. Look at this, what to do. See, we have we have k equals to a e to the power minus ea by rt. Right now this is the Arrhenius equation, and you can write k by a equals to minus ea by rt. Right now, so by sending this e, it becomes ln of k by a equals to minus ea by rt. Right now ea means activational energy here, activation energy here. So you can write this as log, because they given in the terms of log, k by a equals to minus ea by 2.303 rt you can write. And after this, see, they want log k, it means I can write this log a by b form now. So I can write log k minus log a, okay, log k minus log a equals to minus ea by 2.303 rt, and I can send that minus log a from here to this side becomes plus log a, okay, like this you write. Now just compare this equation with the given equation. So as per the equation, so minus ea by 2.303 r is equals to minus 20. Just look at here, by t is there, here also by t is there. So I am removing this t and taking the other part of the equation. So that is the part here. So minus and minus are removed. So ea will be 20 into 2.303 and r we have. So what is the r? See, the units mentioned here as calorie per mole. Calorie per mole means r can be taken as r equals to 2 calorie per Kelvin per mole we can take right now. So you can take here 2 calorie. So becomes how much it is? So 4.646 into 2, 92. Okay. So you will get 92.12 calorie per Kelvin. Okay, per mole. Okay. This is one thing here, and next one is log a. So just compare log a here. Log a is equals to 4. So a will be 10 power 4. Okay, 10 power 4 second inverse. That's it. See, 10 power 4 second inverse. So option number 2 will be perfect answer for this question. Right now, yes. Yeah. So is this clear or not? Yeah. So based on the given data, just compare with the Arrhenius equation and you will get the answer like this. Okay. Right. Let us move forward with few more questions. Yeah. So based on the understanding of previous question, just answer me this question. Just answer me this question. Anyone in the comment box? Yeah. So try this question and tell me in the comment box. Same, whatever the explanation I have given, based on that I have given the question. Yeah. And you can also try this question and write me your answer in the comment box. I will be looking into it. Okay, so thanks for watching. Stay connected with the NEET World channel, and if you are new to this channel, do not forget to subscribe the channel. Thank you.